Math with Wong. Today we're going to look at number 9 of the November 2024 paper 2. As you can see here, we have a trigonometric function question. First part, they're asking for a f at x, and they give you the function 6 cosine pi x. You're asked to write down the amplitude of the function. Well, the amplitude is relatively easy. Amplitude is the a value or absolute value of the a value, but it's a positive number, so the amplitude is just equal to 6. The period, it's always equal to 2 pi divided by the k value. I call this AKDC, so this is the k value. So here, the k value is pi. 2 pi divided by pi is 2, so 1 period is 2 units. Okay, so that's 3 simple marks here. Part B of the question, they give you another function, g at x, and then they say the sum of this function can be expressed in the form of f at x plus g at x equal a new cosine function. Okay, so what do we have to do here? Well, this is a paper 2. And so what you're going to do is you're going to graph this on your graphing calculator. So f at x is equal to 6 cosine pi x, and g at x is equal to -8 sine pi x. So what you're going to do is you're going to go to y1, and you're going to type in 6 cosine pi x minus 8 sine pi x, and then you're going to look at the graph. From the graph, you're going to be able to find your A, B, and C value, right? A is your amplitude, B is 2 pi divided by the period, and C is your horizontal shift. Okay, so I'm gonna graph this on, well, you're gonna do it on a TI-84, and it's gonna look something like this if you grab it. Okay, I'm using decimals here, but you get the idea, right? You're going to get your graphing calculator. You're going to type in y1. You're going to do your graph. You're going to get something like this. By looking at the maximum and the minimum value, right, you should be able to do that on your graphing calculator. The maximum is equal to 10, and the minimum is equal to -10. So the a value is equal to max minus min divided by 2, or in this case, it's pretty obvious that the amplitude is equal to 10, right? You go up by 10, you go down by 10. So here is 10 minus -10, you get 20 divided by 2, which is also equal to 10. So that's the a value, got that. Next, you need to find the b value. The b value is equal to 2 pi divided by the period. Well, how do I find a period on a graphing calculator? Well, you're going to find, again, distance between the top and the top. Right? So what's the x value for this point and what's the x value for this point, right? So you're going to do your second trace and you're going to look for the maximum and look for where the values are, right? So I got 1.70483 for this point, and I got 3.70483 for this point, and if I subtract the two, right, that's the distance. That's going to give me the period. And you can see that 3.7 subtract 1.7, the period is going to equal to 2. So 2 pi divided by 2, they cancel. So the b value is equal to pi. Lastly, we want the horizontal shift, which is the c value. It wants the smallest possible, but it's x minus c. So we're shifting to the right. Right, x minus c, so we shift to the right. And what function do I have? I have a cosine function. Cosine function, we're looking at the top, which is right here. Right, so that means I'm shift to the right by 1.70 if I round up to 3 sig fig. So the value of c is 1.70. Shift to the right by this much. So c value is equal to 1.70, round up to 3 sig fig. Okay, so this question here again, what's confusing is they give you f at x and g at x, right? And people are trying to solve. Well, there's nothing to solve here. Punch in the graphing calculator, look at the new graph that's they provided, and then you do your trigonometric modeling, right? What I call AKDC in class, right? A and C are your vertical transformations, and your K and D is the horizontal transformations. So in this case, the B, right, is 2 pi divided the period. The C is the horizontal shift. For cosine, it's how far I move for the top. So I move over this much for the top. Continue on. It's actually a totally separate question from this point on. We're not using anything in part A, B. It's like a separate question, but they kind of put together as one. They give you a cosine function still, but it's a total different function here. It's a velocity, so it's a kinematics question. So here's the velocity function. And you say, find the time at which the car first reaches its maximum velocity. Okay, so what we can do is we can actually take the derivative and then find where the derivative is equal to 0. And then figure out, whether it's a maximum or minimum. But you say, well, it's only a 1 mark question, right? Why do we do so much work? Well, exactly. This is a paper 2. A paper 2 means you don't have to do all the works by hand. The easiest thing to do is to graph this. You graph it on the graphing calculator and you look for the highest point, the maximum, on the graphing calculator, right? So that's the fastest way to do this, is just to graph it. Obviously, if you want to do algebraically, you can take the derivative and set it equal to 0, and then trying to look for the local maximum. But that's a lot more work. So here's what my graph looks like once I put this in the graphing calculator. Okay, so you're going to get something that looks like this. So this is the velocity function, or negative 4.5 cosine pi over 19 times t minus 4 plus 10.5. It says find the time at which the car first reaches maximum velocity. Well, maximum velocity is going to be right here, right? That's the maximum velocity, because this is the velocity function, via t. So maximum velocity first time is going to be this point. So I'm just going to look. I use my graphing calculator second trace functions and look for the maximum. And the x value here is equal to 23. So find the time at which the car first reaches maximum velocity. Well, 23 seconds later. That's when it first reaches the maximum velocity. Part D, find the number of speed bumps the car passes over in the first 2 minutes of motion. Well, when does the speed bumps happen? Well, the speed bumps is when you have the minimum velocity is when they're passing over a speed bump, right? So anytime that is a speed bump, this is a speed bump, but I want the first 2 minutes. Well, then you can make your domain going from 0 all the way to 120 seconds and see how many minimums you have, right? Now, obviously, you can do it mathematically and count, but really, you have a graphing calculator here, so just change the range, the domain, or the x, the x min and the x max. You just change the x max to like 120. So when you do that, you can just count how many times it hits the the lowest point. So I'm just going to show you from the point of view of a graphing calculator. I know I'm using decimals here because it's easier to get a screenshot than my TI-80 calculators, but it's going to be the same idea. You change your window values from minimum of 0, a maximum of 120 seconds, and you count. 1 speed bump, 2 speed bump, 3 speed bump, 4 speed bump. So the answer for part D is going to be 4 speed bumps. Moving on, part E, you're asked to find the derivative. Okay, well, we can do that. The velocity function is negative 4.5 cosine pi over 19 t minus 4 plus a 10.5. So what's the derivative? Right, you carry down the coefficient. Derivative of cosine is negative sine of the same function. And then you multiply by the chain. The chain is going to be pi over 19. The derivative of 10.5 is 0. I don't have to worry about it. Right? So simplify this a little bit. I'm going to make the 4.5 9 over 2. So that's going to be 9 over 38. So 9 pi over 38 sine pi over 19 t minus 4. That would be the acceleration function. It says hence or otherwise write down the maximum acceleration of the car, right? Maximum acceleration of car is the highest number you can have here. The highest number for sine would equal to 1, right? Sine goes from -1 to +1. So the highest number you can get for this part is 1. So the maximum number of a acceleration would be just 9 pi over 38. Right? If you want to round it off and leave it as a 2 sig fig, 9 pi divided by 38 on my calculator, it would be 0.744. Right? Part F of the question, you're asked to find the distance. Well, that's integration. Right? Integration of what? Well, integration of the velocity function, not acceleration. Between speed bumps. So we're going to go back here and we're going to look at when the speed bumps happen. So the lowest point here to the lowest point here, and we find the x values. So I am getting, where are my graph here? Four to 42. This is t equals to 4. This is t equals to 42. Right? Again, you can integrate and sub in the values and solve, but it's a paper 2. I'm just going to use the graphing calculator. Definite integral 4 to 42. Type in your velocity function. Right? Second trace, 7, I believe. Enter 4, 42. Press enter. They should give you the answer. And the answer should be 399 units. In this case, would be meters. Okay, so this is number 9 of the November 2024 paper 2, which includes some trigonometric modeling, right, in terms of AKDC, the amplitude, the period, and so on and so forth. Here's a combining of function using a graphing calculator. Second half of the question is the kinematics. You're given the velocity function. You want to find the maximum velocity. You want to find the minimum. And when that happens, right, understanding the periods using graphing calculator here, we'll be able to find the answers. And then you're asked to find the derivative acceleration here, understanding a sine maximum is going to be 1. And then lastly, integration of a distance between 2 points. and you just integrate between 4 and 42. Okay. All right. Thank you for watching.